I'm Bob John.
And I'm Brenda Dunn.
Together we formed the Princeton Engineering Anomalies Research Laboratory at Princeton University. Brenda will shortly take you on a tour of some of the devices we employed to display these potential interactions.
You'll see that all of these experimental devices were not only technically precise, but aesthetically appealing. Indeed, most of them were a form of kinetic art. The purpose of the project that we are now proposing is to create an archival museum where all of these devices can be preserved and demonstrated and in fact enjoyed at our ICRL headquarters. ICRL is the organization that we created to carry out the PEAR legacy. This was the PEAR Laboratory, a unique environment in the basement of the School of Engineering and Applied Science at Princeton University. We're going to take a look at some of the unusual experimental devices that constituted the research program at PEAR and give you an idea of their appeal and their precision. We'll start with the random mechanical cascade, a macroscopic device that is known as our pinball machine. This device circulated some 9,000 polystyrene spheres through a maze of 300 and some odd pegs, where they then fell into 19 collecting bins at the bottom, forming a distribution that resembled a standard Gaussian or bell-shaped curve. The task of the operator, seated on a couch about 10 feet away from the device, was to attempt to shift this distribution either to the right or to the left, or to just let the machine run without any stated intention to produce a baseline. In another room in the PEAR complex, we have an array of devices, including our benchmark random event generator, or REG. This device operated very much like a microelectronic coin flipper, producing microscopic events of ones and zeros in trials of 200 each. The operators would attempt to produce numbers that were above the expected mean of 100 or below the expected count, or once again to let the machine run unperturbed in a baseline. The REG lent itself very nicely to other applications, such as an experiment that simulated a racetrack where two operators would compete against each other and attempt to get their car to move faster or slower in accordance with a pre-stated intention. Or an experiment that utilized a big Native American drum with an automated drumstick that was driven by the random event generator and producing alternating hard or soft beats or alternating short or long intervals. This was a very attractive experiment and appealed to a lot of our operators. Another room in the PEAR lab contained a few other experiments of a very different nature, such as this very attractive linear pendulum. The pendulum consisted of a 3-inch crystal ball suspended on a silicon rod that swept back and forth, illuminated by a bright light that changed color as the damping rate of the pendulum varied from faster to slower. A very sensitive detector picked up the movement of the pendulum as it swung back and forth and recorded the velocity very precisely. In the same room as the pendulum, we had another very attractive experiment, a fountain experiment. Again, a very appealing process of a jet of water that's illuminated by a high-intensity light and bounces up and down randomly. The operator's intention here is to attempt to vary the height of that fountain alternately to be higher on the average or lower. Perhaps our most appealing experiment was our robot, driven by an adorable frog who was the pair mascot for many, many years. The robot is driven by an electronic random process that causes it to turn or to move forward or backward, depending on the output of the device. Its trajectory on a circular platform is tracked by an overhead camera that detects the red light at the top of the robot and records the output in a computer file. This experiment actually had two modes of operation. In one case, the operator would attempt to get the robot to move to one side of the table or the other. In the other mode, the operator would attempt to keep the robot on the table longer or get it to move to the edge of the table more quickly.
It's our hope that you folks will help us locate the resources that are obviously going to be needed to assemble this museum and these various exhibits that link us to the history of the PAIR program. As you can understand, this will take some human and some technical effort that needs to be funded in a suitable fashion.